Yes, students, let's discuss image formation in case of concave mirror when object is placed at different positions. So this is our concave mirror and this is the principal axis of the concave mirror. Now we know very well that this is the pole of the mirror. Here, somewhere here would be the principal focus of the mirror, and exactly at the same distance we will have center of curvature. We know that for small aperture mirrors, focal length f, that is distance fp, this is equal to half the radius of curvature. What is radius of curvature? Cp, or you can say Cp is twice the focal length. So that's why Cf and Fp distances are same. Now, the first point is, let's write, this is the position of the object. There is the object. Correspondingly, we will see where the image is formed. We will use simple trigonometry to find out image. We need not memorize it. That's the beauty. So students, once you see the whole video, you will be able to see that there is only one case in case of concave mirror where the image is not real, but the image is virtual. So once you see the complete video, you will come to know that what is the difference between real and virtual image, right? So where the image is formed, we will find the position of the image. Then we will see whether the image is real or virtual. Then we will also see what is the size of the image. See, these are the questions we want to answer. The first and the foremost condition is the object is at infinity. When the object is at infinity, students, the rays from the object, they will come parallel to the principal axis. These are the incident rays. There will be so many incident rays which are falling on the concave mirror when the object is at infinity. Now students, these black colored lines 1, 2, 3, 4, they are the incident lines. They are the incident rays. I can write there also. These are the incident rays. In this direction, they are coming. Now, my red line, they would be the reflected rays. Once they fall on this, on this portion. So you see that this portion is shaded one. This portion is shaded one, and this portion is the reflecting part. This is the reflecting surface of the concave mirror, right? Had this surface be shaded and the bulging part would have been reflecting surface, I would have called this mirror as convex mirror. So guys, you see that now we will understand where are the reflected lines. So the rule is, whenever a ray is coming parallel to principal axis, this is principal axis, this one. So what will happen? The ray will always get reflected and it will pass through focus. Once again, whenever a ray is parallel to principal axis, where is principal axis, students? This is your principal axis. Whenever a ray is parallel to principal axis, it will always pass through focus. So I'll draw other lines also. This will also pass through focus. This will also pass through focus, and after getting reflected, this will also pass through focus. Whenever the rays are coming parallel. Practically, how you can see, you must have seen rays coming from sun, and when you focus those rays using a convex lens, they always get focused on a point, and that cloth or that point starts burning. That is actually the diminished image of the sun formed by the convex lens. But now we are discussing mirror. So I'm just giving you an example. So this is the focus. So we came to know that the image is at the focus when the object is at infinity. In this case, the object is at infinity. Now, what is the size of the image? This is point size image. It's point sized image. Actually, this is the image of the sun. Point sized image. So I will say highly diminished. It's highly diminished. Okay? But this is real. Now, I've told you, once you see the complete video, you'll come to know the difference between a real and virtual image. So I'll tabulate all the data. That object is at infinity, image is at focus. Whether it is real or virtual, it's real. What is size? Size is, it is highly diminished, very small size. Okay. Second point, students. Now, in second condition, what we will do? We will keep moving the mirror close to the concave mirror. Sorry, we will keep moving the object close to the concave mirror, and you will observe as you move object in the right direction towards the concave mirror, your image in case of concave mirror is getting shifted to the left side. You'll see that. Now, the second position is we will place the object somewhere here. Anywhere. You can say beyond C, or you can see between infinity and C. So we will draw once again. Now, here's your concave mirror, guys, and this is your principal axis, right? Now, your black lines. Your black lines are basically the incident rays, but how we will draw them, I'll just tell you. First, you will draw the focus. At the same distance, you will draw center of curvature. Now, the object is here. You can say object is, you could say either it is beyond C, or you can say in between infinity and C. What is C? Center of curvature. So guys, you see that this is your object. Let's say this is the length of the object. You need not memorize where will be image. What you do? What you do, you take the tip of the object and draw a ray parallel to the principal axis. As the rule goes, the ray will always pass through the focus. Perfectly right. This is your incident ray, and this is your reflected ray from the concave mirror. Outer area is shaded, inner area, concave area is reflecting surface. So the other ray you would draw from the tip of the object, and it should pass through C. Let me draw that. So I will draw a ray from the tip of the object passing through C. Just see, students, where it intersects the ray coming from the focus. It intersects at this point. I may name this point as O. Now, this is the size of the object. Now, if you see slightly, the image is diminished. Image is diminished. Now, students, this object is placed erect. This is erect because it is, it's like over the principal axis, this axis, principal axis. But this image is formed below the principal axis, and hence I will say this image is inverted. This image is inverted. And how will I draw? This is the image, students. This is the image, right? This arrow shows your image, and that is slightly diminished. And where the image is formed, students? Image is formed between C and F. Let me tabulate this. When the object is what? Object is beyond C. The image is between C and F. It is real. You'll come to know the meaning of this. Don't worry. The size is, it is slightly diminished. Slightly less. You could draw it with scale and you will see 2 mm, it will be less. And now there's one more column, whether it is erect or it is inverted. So any image which is made below the principal axis like this is inverted. So this is inverted. In first case, you cannot say this is erect. You can't say it's inverted. Why? Because this is point sized. No? The image is point sized when the object was at an infinity. Now, students, we will move the object little more on the right side. So we will keep the object on the C, and let's see where the image is formed. Right? So we will keep the object at C, and let's see where the image will be formed. All right, students. So here again, this is your concave mirror. This is your principal axis, right? And this is your F. You can say this is my F. At the same distance, this is my C. Object is placed over C. Let's say this is the size of the object. When the object is placed over C, same rule. The first line we will draw from the tip of the object parallel to the principal axis. It will always pass through what? It will always pass through principal focus. The second ray should be from the tip of the object passing through C. So it will be like this. Students, where these lines are intersecting will give you the size of the image. So interestingly, let's say this is the image, and you can see, students, this size and this size is exactly same, and the image is also made on C only. So you have seen initially when the object was at infinity, image was at F. When the object moved right side beyond C, the image moved little left side. Here image was here. It was between C and F. When the object moved from here to here at C, the image also moved. Initially it was between C and F to C. Very right. Let me tabulate the readings I've got at C, and also the image is at C. It is real. The size is exactly same. Students, this is the only case in which the image size is same exactly as the size of the object, and that is when the object is placed at C, at center of curvature. So it is inverted. This is also, it is inverted. Now from C, we will move the object between C and F, right? The fifth one would be, we will again move it right side between C and F. From C, we will move to F. And the sixth one, we will place the object between F and P, the pole. So this is the case where, which will be a little bit more interesting. All right. So between C and F, all right. So when we draw the image between C and F, let's see what happens. See, students, Yes, students. Now we are going to place our object between C and F. So as the rule goes, first ray from the tip of the object parallel to principal axis, it will always get reflected from the surface of the concave mirror. It will pass through F. Always, whenever you place whenever there's a ray parallel to principal axis, it will pass through principal focus. And the second one, from the tip of the object, it will pass through C. You see, students, where is the image? Image in the last case was at C, object was at C, image was at C. Now the object has been moved right side. Between C and F, the image has again moved left side. And students, you see, where is the image? You will come to know where is the image. You just draw an arrow from this point to this point. This is the image. Very interestingly, you need not remember, you can see it that the image, size of the image is more than the size of the object. Very interesting. This is the size of the object, which is erect over the principal axis. This is the size of the image, which is below the principal axis, right? So image is formed beyond C, right? And it is inverted and it is bigger in size. Let me tabulate the data. When the object is between C and F, the image is beyond C, or you can say between infinity and C. The image is real and the size is, it is magnified. Magnified means the size is more than the actual size of the object, and it is inverted. Now we will place the object at F. Students, very interesting. When you place the object at infinity, image was at F. Reverse. When you place the object at focus, the image will be at infinity. See how the image is formed at infinity. Very interesting. All right, students. Now we will draw the case when object is at focus. Let's say this is the object. This is at focus. Again, the same principle. From the tip of the object, draw a parallel line, right? And the parallel line will always pass through focus, right, students? And the other line, other ray we have to draw from the tip of the object, passing through C. You can see students have not done any adjustments. These two lines are perfectly parallel lines. And can you please tell me where the parallel lines meet? They meet at infinity. Because the thumb rule is how we in every case do the image. We draw the image. First ray was from tip of the object parallel to principal axis, where this reflected ray is basically intersecting the ray from the tip of the object passing through C, but they are not getting intersected. So we will say, it's just saying that they will intersect at infinity, or in other words, the image will be at infinity. All right, guys. Now we will see the last one. Yes, students. Now we are going to discuss the last case. Now the object is, students, between principal focus and pole. This is the object. I'm going to draw. I cannot draw a line parallel now because it has crossed F. It has crossed F. I cannot draw a parallel line. Now I will draw a ray, using, and let's say this ray is, touching the P. So when the ray is touching P, from the tip, we will draw the ray touching the P. Now this is the angle of incidence, students. This is the angle of incidence. So as per the rule of reflection, the same should be the angle of reflection. So where would be the reflected ray? Reflected ray will be here. Am I right? Now the second one, you draw the from the tip of the object passing through C. Now students, an interesting thing is happening. What is that interesting thing? These two lines are not intersecting and hence the image will not be real. Now you understood the meaning of real image is when the two rays, reflected rays, are not meeting. Now we have to extend them backwards. We have to extend them backwards. I'll tell you how to extend them backwards to see the location of the image. You know, give me 1 second. This is our this thing. So, okay, this is our reflected line. Now we will extend it backwards, students, and see where they intersect. Now, see students, this is the ray I've extended backwards. And now I'm extending this ray. You see, very interesting. These rays are not actual rays, students. These two rays, try to understand. This ray, this one and this one are not reflected rays. The reflected rays are, try to understand. This was the ray, incident ray on point P, and this is the reflected ray. The reflected ray is actually extended backwards, you know, to meet at point P. All right, guys. Now, where will be the image, students? The image will be only in this case, in case of concave mirror, dear students, the image would be erect. This is the image. Image is erect because it is above the principal axis. This is your object, students, and this is your image. Image is, you can see, yes, Shamir, whether the image is smaller than object or bigger than object?
So bigger.
Bigger. So you need not remember anything. The object, the image is bigger. Now, students, the lines have not actually met. This line and this line will never meet. We have extended them backwards to meet on the backside of the concave mirror, and hence this image is known as virtual image. Like when you stand in front of a plane mirror, you know, your image is on the backside of the mirror. That is virtual image. That image cannot be brought on a screen. Now, students, if you see all these cases, in all these cases, let's say this case, when the object was, in this case, beyond C, the image is between C and F. So, if you keep, students, if you keep some screen here, exactly on this point, inverted image will be there. Imagine if this is a candle. So, lesser the size of the candle, inverted image will be shown on the screen. This is your screen. If you want, you can put a screen here, maybe a mesh, or maybe anything. There are screens available. So the image will be seen when the image is real. When these lines, reflected lines, are actually intersecting, the real image will be there. But in this case, students, only in this case, when the object is between F and P, the image is virtual. This is the case of virtual image, and the image is little bigger in size, or you say it's magnified, and it is erect. So this case is quite different from all the cases. In all the cases, we had inverted image in case of concave mirror. But in this case, we are having what? We are having erect image. It is above the principal axis. This is your principal axis. and at the same time, the image is virtual. So let's tabulate the data. So when the object was at F, image was at infinity. The image, you cannot really say it's real or this thing. Why? Because, you cannot say anything about this. But all right, you want to say, you can say it's real. But the lines are not meeting. So now the size, when the object is at F, yes, students, when the object is at focus, image is at infinity. Let's see this case where it was when it was at infinity. I think I've grabbed it. So basically, and when you see when these lines are meeting at infinity, so they'll be very, very, very much below the principal axis. So I could say that it is highly enlarged. The image size would be highly enlarged, you say, or you say magnified, no problem. It will be inverted. Why? Because it is below the principal axis. And yes, you could say it's real image because the lines are there. Lines are not actually meeting, but we assume that the lines are meeting at infinity, so we say real. When the object is at F and P, this is the last case. The image is what you will say? Beyond P, or you say backside of mirror. Backside of concave mirror. And you see, students, the image is virtual. Only in this case, the lines are not actually intersecting, but we are making the lines. These are the lines. We are extending the lines backwards and making them meet at this point. So that's why we say the image is virtual. All right. The size it is enlarged. You have seen the object was this and the image was this, and it is erect. So see, students, we have covered all the cases. Hope you have understood. If you have any doubt, I would request you that you just pause the video, write down your doubt. I will try the maximum to answer your question. If you like it, do share with your friends and see the video completely to understand it completely. Thank you very much.